Welcome to Study Loop.
So let's draw a diagram going straight down, going at an angle here. Let's redraw that. Okay, so here, this would be our angle 45 degrees. Let's draw a dashed line here. This would be our theta, and this vector here would be, of course, be our velocity of the air relative to the ground. This would be the velocity of the plane relative to the ground. This would be the velocity of the plane relative to the air. And so at this point, we can say that the velocity of the plane relative to the ground would be equal to the velocity of the plane relative to the air plus the velocity of the air relative to the ground. Let's equate the x components of the velocity vectors. We can say that here, we know the magnitude of the velocity of the plane relative to the ground is 135 kilometers per hour. So we can say 135 kilometers per hour multiplied by cosine of 45 degrees would be equal to 0 plus the velocity of the wind in the y direction. So the velocity of the wind in the y direction would be equal to, or rather, in the x direction, my apologies. This would be 95.5 kilometers per hour. Now let's equate the y components. So we can say negative 135 sine of 45 degrees would equal negative 185 plus the velocity of the wind in the y direction. We can say the velocity of the wind in the y direction would be equal to 89.5 kilometers per hour. And so we can solve for the magnitude. This would be equal to 95.5 squared plus 89.5 squared, all to the 1/2 power. This is giving us 131 kilometers per hour. So this would be your magnitude. And then to find a direction of the wind, we can say theta would be equal to arctan of the velocity of the wind in the y direction divided by the velocity of the wind in the x direction. So this would be equal to arctan of 89.5 divided by 95.5. And this is equaling 43.1 degrees north of east. So that would be the direction. That is the end of the solution. Thank you for watching.